Every object that goes up must come down. This is a very common phrase, you must have heard it already. But this is not true in particular cases, or to be more precise, for particular velocities. Now consider this object. If I throw this object upward in the sky with a certain amount of velocity, it will never come down. It will escape the gravitational pull of the earth forever. And that velocity is called the escape velocity. So I'm going to derive the formula for escape velocity now.
Now suppose consider this as our earth. Let's call it as it is of mass capital M and radius r. And this is an object of lying on the surface of the earth of mass m, a small object of mass m, and it is thrown with a velocity upward in the sky with a velocity, let's call it v. Now applying energy conservation, E initial is equal to E final. E initial is equal to E final. And this is the escape velocity, and this is the escape velocity of mass m. So applying energy conservation, initial energy is, that is the gravitational potential energy, minus g m upon r, that is the radius of the earth, plus kinetic energy of this object, half m v escape square. And the final energy, since it is going to infinity, the final energy, gravitational potential energy, is 0, and kinetic energy is also 0, so it is 0. So half m v escape square is equal to g m divided by r, and v escape is equal to under root 2 gm divided by r, and that is the escape velocity of an object from the surface of the earth. Here mass is, capital M is the mass of the earth, and capital R is the radius of the earth, and capital M is about 6 into 10 to the power 24 kilogram for earth, and the radius is 6400 into 10 to the power 3 meter. If you put these values here, and we know gravitational constant value, escape velocity is come out to be 11.2 kilometer per second. So if you throw an object with the velocity 11.2 kilometer per second here on the surface of the earth, it will never come down. It will forever escape from the gravitational potential pull of the earth. So we have successfully calculated the escape velocity formula, that is under root 2 gm divided by r. Here mass can be the mass of an object out there in the universe, compact object or planet or a star or anything else, and radius is the radius of that object. Now suppose, consider that case, there is a compact object out there in the universe which is having escape velocity is equal to the speed of light. V escape is equal to the speed of light for that compact object out there in the universe. And we all know what that compact object out there in the universe is, which is completely dark, and not even light cannot escape the gravitational pull of that compact object. And that compact object is called as black hole. Black hole. Not even light can escape the gravitational pull of that black hole. So that is why the black hole is appearing as completely dark. So if I apply the equations, let's put V escape is equal to C in that equation. So C, that is the speed of light, is equal to under root 2 gm divided by r, where mass is the mass of black hole and radius is radius of the event horizon of the black hole. So now solving for r, c square is equal to 2gm divided by r, and r is 2gm divided by c square, and that is the formula for radius of the event horizon of a black hole. If you know the mass of the black hole, you can calculate the size of the black hole, and this is called the Schwarzschild equation. Schwarzschild derived this equation for the first time. So it is called Schwarzschild equation. We all know the speed of the light, which is c is equal to 3 into 10 to the power 8, 10 to the power 8 meter per second. And now, interestingly, if you want to make Earth as a black hole, you only have to condense Earth to a particular size. Then it will become a black hole. Now, suppose if I put the mass here as the mass of the Earth, m is equal to 6 into 10 to the power 4, 24 kilogram. Then r is equal to 2g, that is, we all know gravitational constant, 6 into 10 to the power 24 upon 3 into 10 to the power 8, the whole square. Then r has come out to be approximately about 3 kilometer. So what you have to do is, in order to make Earth a black hole, just condense Earth into a 3 kilometer radius sphere, and it will become a black hole. That is a very interesting point. So any object can be converted into a black hole if you just condense it to a particular limit that is given by this equation, that is Schwarzschild equation.